Hello, and welcome to today's session on Amazon SageMaker Data Wrangler. Data Wrangler is one of the new capabilities we're launching this year as part of SageMaker Studio, which is our interactive development environment for data scientists. Data Wrangler has been specifically designed to help data scientists prepare their data for machine learning. My name's Ajay Sharma, and I'm a product manager here on the Amazon SageMaker team. I'm personally really excited to talk to you about Data Wrangler because whenever my colleagues and even myself have had to prepare data for machine learning, we've always found data prep to be a really time-consuming process. So without further ado, let's jump in and talk a little bit about our agenda for today. We'll start off with a bit about the state of data preparation today and the challenges associated with data preparation. We'll then introduce our new capability, Data Wrangler, designed to help data scientists with these data preparation-related challenges. Next, we'll do something really exciting and give you all a test drive of Data Wrangler with a demo. Finally, we'll conclude by discussing how our partners and customers are using Data Wrangler to accelerate their machine learning and data preparation needs today. First of all, what do we mean when we talk about data wrangling? As you may recall, it's rare that we ever get clean data that's ready for model training. Many data scientists see model training and validation as the icing on the cake. But before we can get to training a model, we first need data. After we find our data, we need to analyze and understand it. Once we've understood the data that we're working with, we need to check the data for any inconsistencies, as well as any potential issues our data may have, which could lead to a skewed outcome once we've trained our model. Finally, once we've prepared our data for model training, we want to make sure that we can save the features we've created so that we and others can reuse those features in our machine learning workflows. Let's talk a little bit about the challenges associated with data preparation today. First of all, data preparation is a time-consuming process for many data scientists. On average, we hear that data scientists spend up to 60% of their time on data preparation-related tasks. Additionally, data prep can require the use of several tools for tasks like data selection, data cleaning, feature engineering, visualization, model prototyping, and production. Common data prep tasks such as auditing data for missing values and imputing them, as well as outlier detection, typically require writing code by hand. Additionally, when moving data prep workflows to production, engineers sometimes have to manually rewrite and translate code into something more production-ready, like Spark, from something more data science-friendly like Pandas. Finally, this whole process of turning raw data into machine learning data can involve a lot of back and forth and take a team of data scientists, analysts, and engineers months. So what's our answer to all of this? Well, we're proud to introduce Amazon SageMaker Data Wrangler, which features the following core capabilities. First, we provide a visual interface that allows users to quickly select and query data. Next, we have a collection of over 100 built-in transforms to help users prepare their data without writing a line of code. With Data Wrangler, you can also write your own feature transformations using PySpark, SQL, and Pandas. Data Wrangler also features a visual interface to help generate an intuitive understanding of your data. It includes a model preview feature that allows you to get an estimate on model accuracy. And finally, we enable users to take their data prep into production with a single click. Let's dive into each of these features in detail. Preparing high-quality training data often requires the collection of data in various formats from different sources and can even require writing complicated queries. With SageMaker Data Wrangler's data selection tool, you can quickly select data from several data sources, such as Amazon Athena, Redshift, Lake Formation, S3, and data from SageMaker Feature Store. You can write queries for data sources and easily import data in various file formats, such as CSV files, Parquet files, and database tables directly into Data Wrangler. Before importing large volumes of data from various data sources, you can query and preview your data from the visual interface, all from Data Wrangler. Next, let's learn how Data Wrangler can help you transform your data. SageMaker Data Wrangler comes pre-configured with over 300 transforms. These data transforms help you with a wide variety of data prep tasks, and the best part is you don't even need to write any code to be able to use them. I've rarely seen a dataset that didn't need you to handle missing data, so Data Wrangler helps you with that by providing a tool to help you fill in missing data. Additionally, Data Wrangler gives you a way to easily detect and handle outliers in your dataset. You simply indicate the column and the outlier strategy you want to use, and Data Wrangler takes care of the rest. Data Wrangler also has tools to help you automatically generate features from your string and datetime valued data. In addition, we've also got transforms to help you move around and rearrange columns, as well as several transforms to easily clean and process string value datasets. Data Wrangler's data visualizations can help you intuitively understand your data. Data Wrangler comes with a few preset visualizations built in. These include standard histogram and scatter plots. We also include a tabular summary, which returns summary statistics for each column of your dataset, such as min, max, mean, standard deviation, and record counts for each column. We also include a bias report capability, which has also launched this re:Invent, known as SageMaker Clarify, which provides metrics on your dataset that tell you if your data could result in a skewed or biased model. We also feature a custom visualization code input, so if you want to use a visualization by writing your own code, you can do that too. Data Wrangler supports visualizations written in Altair. Finally, you can save all of these visualizations to your flow if you want to refer to them later on. Next, let's learn about Data Wrangler's quick modeling capability. SageMaker Data Wrangler's quick model capability helps you quickly identify inconsistencies in your data and diagnose issues before your models are even deployed to production. With the click of a button, you can get a high-level estimate of model performance against a target variable that you specify. For example, for a classification problem, you can quickly get F1 metrics, and for regression problems, you can quickly estimate the mean squared error. Under the hood, we train a random forest over a 70-30 train test split on your data, and we output the metrics from that model onto the interface. You can quickly see which features are important relative to others based on your data preparation workflow. Data scientists have told us, many times they are asked to quickly run a model or give a high-level estimate on do we have enough data to build a model or do we need more data. Data Wrangler's preview modeling capability is designed to give you a rapid response to these pressing questions. Customers have told us that this has been a huge time saver for iteratively refining the features and improving model accuracy. And you can do all of that within Data Wrangler without having to train a model from scratch. Next, let's learn about how Data Wrangler can help you go to production with a single click. With Data Wrangler, you can easily take code into production, and you can do this without manually sifting through and translating hundreds of lines of data preparation code. You can export your data prep workflow to a Data Wrangler job notebook with a single click to easily bring your data prep workflows into production. You can also integrate your data prep workflow with SageMaker ML pipelines to automate model deployment and management. With Data Wrangler, you can publish features that you've created to SageMaker Feature Store for future reuse and sharing across your organization. Finally, you can take everything you've done in Data Wrangler and export it directly to Python code for easy reuse in other production environments. Now it's time to take Data Wrangler for a spin and show you what it can do. In the following demo, we're going to be real life data scientists and use Data Wrangler to solve a data science problem. We're going to show you how you can use Data Wrangler to import data from S3, Athena, and Redshift. We'll show you how you can explore it and visualize it, and we'll show you a few data cleaning steps to join data sources together and start extracting features. We'll use Data Wrangler to get a ballpark estimate on a model, and finally, we'll export everything we've done to production. In this part of our session, we'll be taking Data Wrangler for a test drive to showcase all of its new features that will help you prepare your data for machine learning. Let's pretend for a moment that we've recently joined a major airline as a data scientist. We've just received the following email. Hello there, fellow data scientists. Welcome aboard. We're building a new feature for our mobile app that will tell our users if one of their flights has a chance of being delayed. I'm sending over some raw airline flight data for you to prepare to see if you can get the data ready to be used for a machine learning model. A few notes. We'll need your help with preparing the data for this new feature. You can find the data on S3 and the Athena and Redshift databases. The variable dep delay tells you by how long a flight was delayed. A value of 0 means there was no delay and the flight was on time. A value of 10 means the flight was delayed 10 minutes. A value of -10 here means that the flight departed 10 minutes early. Turn this variable into a binary indicator variable to describe flights that were late versus not late. Check the data for missing records. If there aren't too many, you can probably safely ignore them. You may find it hard to figure out the airport name or location from the 3-letter abbreviation. There's an airport table on S3 that you can join to the data to help you figure this out. For example, you'll be able to map SFO to San Francisco International. Okay, now get started. We can create a new Data Wrangler flow to help us with this task by going to File, New, and clicking on Flow. This creates a new Data Wrangler flow that we can use to prepare our data. Let's start by exploring data in Athena. While it's connecting to the engine, you can see that there are 4 main capabilities inside of Data Wrangler. First is import, where you import your data into the data preparation environment. Next is prepare, where you prepare individual data sets. Third, you can analyze those data sets using a variety of pre-built graphics and visualizations. And fourth is export, which allows you to take what you've built inside of Data Wrangler into production. Let's start by importing some data. We'll click on the Athena button, and we can select our data catalog. We can also select the database that our data is in. We'll use Airlines Demo for this example. On the right-hand side, we can see the tables that are in this database. Currently, there's only one table in this database. Clicking on the link allows us to preview the table that's inside of this database. On the left-hand side, we can see all the columns that are in this table. And on the right-hand side, we can actually see a preview of data that's inside of this table. We click Done. Now let's write a simple query to select some data from this table. Let's select all the flights from the airlines table where their origin is in SFO or LAX. We can run the query. And see the results below. We can verify the results are right by going to the origin column and verifying that all the flights we've selected are the flights departing from either LAX or SFO. This query looks right, so let's go ahead and import it into our data preparation environment. We can give it a name. Let's call it SFO LAX flights. Once we've imported the data, it shows up on our data flow view. This view gives us a top-down view into all the data sets we've imported into Data Wrangler. Let's now pull in another data set, which will help us disambiguate the 3-letter flight airline abbreviations and give us the full name and location of each airport. We go back to the Import tab, and we click on S3. Clicking on S3 will show us all the buckets that we have access to. We can click on the airline's data, navigate to the airport's data folder, and select the airports.csv file. Data Wrangler supports importing both CSV and Parquet files. We'll hit Disable on Sampling because the file is small enough. We can enable sampling to ensure that we have an interactive data preparation experience inside of Data Wrangler. Let's go ahead and import this data set. As you can see, this data set's shown up on our data flow view. Let's try to join these two data sets together. We click on the plus and we select Join. Selecting Join takes us into the Join wizard, which allows us to join different data sets together. Let's zoom out a bit, and let's click on the data set we wish to join to this table. As you can see, Data Wrangler gives you a preview of the join table that's going to come out from this merge. Let's go to Configure. We can select the join type, as well as the columns that we want to join on. We're joining on origin, which on the left-hand side represents the airports that the flights are leaving from. And on the right-hand side, we're going to use the column IATA, which is the same code. Clicking on Apply completes the join and shows us a preview below. We can verify that the join took place by checking that a flight from SFO should also now have the full name of the airport added to the end. Let's see. SFO, San Francisco International. We have the city, the state, the country, as well as the latitude and longitude. This looks good, so let's go ahead and add that to our data flow. As you can see, the joined dataset has shown up on the data flow view. We've joined together the flight data along with the airport data. Let's take a look at this data and see if we can do some basic feature engineering and data preparation. We click on the plus and we click on Add Transform. Clicking on Add Transform takes us to a Prepare view. On the left-hand side, you can see the data that we've joined together. And on the right-hand side are all of the different transformations that come with Mojave out of the box that allow you to prepare your data. We were told to look at the dependent variable known as departure delay. Let's see if we can find that column here. Here it is. Departure delay. This column tells us how many minutes a flight was delayed. A value of -5 indicates that the flight actually departed early by 5 minutes. And the value of 18 here indicates that the flight left 18 minutes late. As you can see, we also have some missing values. Let's see if we can transform this data, clean it up, and create a dependent variable that we can use for modeling. The first thing let's try to do is remove the missing values. On the right-hand side, we notice that there is a handle missing transform. Let's click on that and see if we can use it to get rid of any missing observations in our dataset. Clicking on handle missing expands the menu and shows us a variety of different choices. We're going to choose to drop missing. We're also going to indicate to Data Wrangler to drop all rows where there's a missing value. Now normally you'd want to make sure to check that there's not too many of these missing values so you don't bias or inadvertently remove too many data points from your data set. Let's select the column that we're using to drop the missing values from, and we can preview the change. Previewing the change shows us that now all the missing values are gone, meaning all rows that contained a missing value for this column have been removed. This looks right. Let's go ahead and add this step. Clicking on previous steps allows you to view the various different steps that you've added to your data flow. We can go back to our data flow and we can see that this step that we've added has now been added to our data flow graph. What the data flow graph is telling us is that we've imported two different data sets, one with the flights, one with airports. We've joined them together, and we've removed all missing values that were in the departure delay column. Let's see if we can handle some outliers in this data set using a built-in transform. As we can see, Data Wrangler has a Handle Outliers transform that allows you to seamlessly handle your outliers. We'll use the default standard deviation numeric outliers, and the column we're going to try and trim our outliers from is the departure delay column. Let's create a new column called Departure Delay No Outliers. The fix method we'll use is to clip, which will basically trim all outliers and cap them to the lower and upper bounds. Let's preview the step find the column, and see if there are any extreme values. There don't appear to be values that are too far extreme, so this looks right. Let's go ahead and add this step to our data flow. We can see that a third step has been added, and if we go back to the data flow view, we can see now that there are two steps here. First was handle the missing values. Second was handling the outliers. Let's see if we can create a binary indicator variable that'll define for each flight if it was late or not. We click on the plus and go to Add Transform. We'll use Data Wrangler's custom formula tool to create a new column that'll indicate for each flight whether it was late or not. We can use a simple Spark SQL expression to create this column. We'll say, if the flight was delayed, and we'll use the new column that we created that was named No Outliers. And we can check that. Departure delay, no outliers. If the departure delay was greater than 0, meaning that there was a delay, we'll say the flight was late. Otherwise, we'll say it was not late. We'll call this variable late flight. Let's preview the change. And we can see that a flight that left 5 minutes early was indeed not late, yet a flight that left 18 minutes late was late. It looks like this transformation is correct. Let's go ahead and add this step to our data flow and confirm, indeed, we've added 3 steps in addition to the join. We can go back and verify this on the data flow graph. A third step has been added, and it is a custom formula that we've written ourselves to create that new column. Let's now explore Data Wrangler's visualization capabilities. We can click on plus and click on Add Analysis. As you can see, we've been taken to the Analyze tab, which we can use to visualize our data. Let's visualize the delayed departure times to see what the spread of departure delays looks like. We can go to x-axis, search for the column that we created, departure delay, no outliers, and Data Wrangler will render the histogram for us. As we can see, most flights leave within about an hour of their departure time, and there are a few that tend to leave a fair amount later. We can go ahead and create this visualization, and it'll be saved. We can actually go ahead and create another one. This time, let's create a scatter plot. Let's plot departure delays versus departure time. Perhaps we have a hypothesis that the later a flight departs in the day, the more likely it is to be delayed. We'll set the x-axis to the departure time and the y-axis to the departure delay. It's a bit hard to tell from this plot, but it does look like as flights go later in the day, there do seem to be more later departures. Let's go ahead and save this visualization. Let's give it a name. We'll call it Delays versus Time. As you can see, we now have 2 visualizations that we've created. Let's go back and take a subset of columns from our dataset and try to fit a quick model using Data Wrangler's quick model capability. We'll go here and click on the plus and click on Add Transform. We'll use Data Wrangler's custom transform to write some SQL code to subset this data set to only the columns we need to train a model on. all this query is saying is to pick out all of these columns from our data set and leave the rest. Let's preview this step. It looks like I used the wrong column name, and I actually gave it a new name for my example. Let's use the correct name, which is late flight instead of is late. Let's try again. It looks like the command worked, and we've only got the columns we want to fit a model on. We've saved the date, the quarter, the month, the day of the month, day of the week, the origin and destination, the departure time, the elapsed time of the flight, the distance of the flight, the latitude and longitude, and whether or not the flight was late or not, which we will use as our dependent variable. Let's go ahead and add this step to our data flow. Let's go back and see that we've indeed added the fourth step. Now let's go and try to fit a model on this data set. We can click on the plus and click on Add Analysis. Let's go ahead and select Data Wrangler's Quick Model tool. We're going to try and predict if the flight was late. And let's select that label that we've created, late flight. Now, what Data Wrangler is doing is it's taking a 70%, 30% train test split on our data set, and it's actually training a random forest classifier against this late flight variable that we've created. Once it's done training, it'll show us the results of the model that it's trained, and it'll present us with a view of the important features that could be potentially predictive of a late flight. It looks like the following variables are predictive of a late flight: departure time, destination, month, and actual elapsed time. Furthermore, the model has achieved an F1 score of 48.2. This tells us that we may want to look further deeper into departure time and destination and see if we can use this to come up with more interesting features that could potentially help us improve the score of this model. Let's now look at how we can take what we've done in Data Wrangler and export it to a processing job that we can run as part of an end-to-end ML pipeline. We can click on the Export button over here and select the node that we want to export. Selecting this node will create a notebook that contains all of the instructions required to run this entire data flow that we've authored inside of Data Wrangler. Data Wrangler provides 4 options to export our work. First, we can export it as a Jupyter notebook that launches a Data Wrangler job. Additionally, we could export this notebook as an ML pipeline to create our own new machine learning pipeline from which we could run a complete end-to-end machine learning workflow on. We can also export the entire flow that we've created as raw Python code that could be then run elsewhere. In addition, we can take all of the features we've created and all the data processing steps we've performed and export that data into the feature store. Let's look at the notebook that runs the Data Wrangler job. Selecting the Data Wrangler job option will now open the notebook in a separate tab. Let's select the data science kernel. Running this entire notebook will kick off a processing job that'll execute this entire data flow steps that we've authored in Data Wrangler. You could then take the results from this Data Wrangler job and kick off a SageMaker training job, which is also provided inside this notebook as well. Additionally, you could go ahead and choose to deploy this model or embed this entire workflow into an end-to-end machine learning pipeline. As you can see, in a matter of minutes, we've imported data, we've processed it, we've joined it, and we've actually exported everything we've done into a repeatable and scalable SageMaker Data Wrangler job. Now that you've had a chance to see Data Wrangler in action, I'd love to tell you a little bit about some of the special partnerships we have coming up with Data Wrangler in 2021, as well as talk about how our customers are using Data Wrangler to accelerate their data preparation needs today. Customers have asked us to make it even easier for them to connect to their favorite data sources from within SageMaker. We're really excited to announce that in 2021, we'll have native support from Data Wrangler to connect to Snowflake, Databricks Delta Lake, and MongoDB Atlas, so that customers can easily prepare their data from these sources inside of Data Wrangler. I'd also like to mention some of the specific customers who have already started leveraging the power of Data Wrangler to prepare their data for machine learning. We're really excited to share that several customers have already started using Data Wrangler to accelerate their data prep needs today. These include DNA, Invista, Deloitte, 3M, and Nomura Research Institute. These customers have told us that they're really excited with the promise that Data Wrangler brings to help them kickstart their data prep into high gear, helping them scale data prep pipelines to effortlessly handle millions of rows and reduce the time to deploy ML pipelines from a month to a matter of days. Customers have told us that the amount of data they have to prepare is only growing in volume. Being able to rapidly prepare and extract insight from data is mission critical to their success, and our customers have been able to leverage Data Wrangler to help them do exactly that. Now I'd like to tell you how you can get access to Data Wrangler to start preparing your data for machine learning today. First, you can access Data Wrangler from inside of SageMaker Studio. Simply go to File, click New, and select Flow. This will open up a new Data Wrangler flow, which you can use to get started preparing your data right away. You can check out Data Wrangler on the SageMaker homepage, where we have blog posts and other tutorial material to help you go deeper into your Data Wrangler experience. Finally, if you have questions or feedback on Data Wrangler, we invite you to post on AWS developer forums. Thanks for attending this session on Data Wrangler. We really can't wait to hear about how Data Wrangler is helping you accelerate data preparation for all of your machine learning needs. Thanks.